Okay, if everyone is okay, looks everyone is okay. Okay, so we start question 1, week 4, tutorial handout question 1. An automobile has a mass of 1,215 kilograms. It's automobile. It travel with the speed 2 meters per second speed toward the wall, crash the wall. Okay, if the impact occurs in 0.06 seconds time per 6 seconds, determine average imposed force acting on the car. This means this car without brake just drive with this speed and hit on this wall. Ask you find out what is average impact force or imposed force. This is very simple. Just F delta T equal to, because end of the impact velocity equals 0, so equal to mv. Okay, mv minus 0. The end of momentum equals 0, and that's straight away you can get mv ft. You can straight away you get the impact force equal to mass times speed divided by the time interval. Then you get 40,500 Newton. This is straight away. Okay. So what's your question? Week 3, question 5 done. Yeah, we later on do the week 3 question 5. Okay, so we do this. We catch up first. Okay. Anyway, we have a pre-recording, and if you want interesting, go to week 3 question recording. You can find. If I have spare time, we can start there. Okay. So now we go to. Okay, the first question already answered. From this one, I get the 40,500 Newton. The second one is is assumed, and the brake are not applied in this case. And the second one, if the coefficient of kinetic friction, a coefficient between the wheel and the pavement is the 0.3, okay, and then calculates the import force on the wall if the brake were applied during the crash. Apply the brake, okay, and when they apply the brake, and the brake should be applied to all the 4 wheels and make lock up the wheels, make whole wheels slip, lock up in this condition. Okay, we do the some force analysis. We study if we have this is traction force. If engine drive this car, traction force should be balanced by the friction force, and also this the wall have a reaction force. This wall reaction force plus the friction force equal to driving traction force. Okay, for vertical is you have a reaction force M, normal reaction force M, and the gravity force, which is the weight. Yeah. So sigma F for x equal to 0. So which means you get for traction force equal to reaction force. This is wall reaction force plus the friction force. Okay, and this one should be equal to this is your equal to this force. Okay, and then the vertical direction is n equal to mg. All right, so then you traction force with the traction force hit the wall, ft multiplied t delta t. Okay, so this is equal to momentum, the beginning momentum minus the end of momentum equal to 0. Okay, in this case you have 2 parts. One is and the reaction force of the wall. Another one is the friction force. In this case, friction force equal to m equal to mg. So 0.3 times m, okay, times m, which is mg, and multiply t is 0.06 seconds, equal to the momentum. And from here, you can solve this reaction force of the wall, Fi, which is impact force, and which equal to this one divided by first one, this one divided by the time, and the minus this term divided by time, and the minus this term, minus 0.3 this term, and then you calculate, you get the 36,927.9 Newton. Get this result. Okay, so you can that's how you solve this problem. Okay, very simple. If you want to calculate, I can show you the calculation is very simple. So And we can have a look. So I think you understand that this is traction force equal to the wall reaction force plus friction. Friction equal to friction coefficient times n equal to mg. So this mu equals 0.3 times mg. It's mg, right? So this is total traction force, which is this one. Traction times delta t equal to mv. So that's why you get this one divided by time this 0.06 divided 0.06 and minus this term, and you get this force. And then you calculate very simple calculator. You can check the calculation is correct, not correct. We have calculation. So equal to 1215 multiply 2 divided by 0.06, yeah, minus 0.3 and multiply 1215 by 9.8. So you can type in this formula inside and enter, you get the results. 36927, that's your result. You compare this result is the same, and they compare your standard answer the results. Standard answer is 36900. What I get? 36927. It's close. Okay, too close. It's a close. Okay, and the first result 40,500. First result we get 40,500. Get exactly the same. Okay, then we move to question 2. So question 2 is two car A and car B. Okay, and the car A, car B have the mass, both have mass 80 kilogram. All right. If the man C have a mass 70 kilogram and jump from A with the horizontal relative speeds with VC VA equal 2 meter. From here, jumped over with relative speed 2 meter per second. This jump the relative speed. Because if this guy jump from this car, jump off, and then we'll push this car go to this direction. We have feeling, that's normal feeling. Jump over, push the car in this direction. And jump over, this car will go to this direction. That's our common sense for that. Okay. And then the car B, determine what is speed of each car after the jump. That's the question. Okay. We ignore negligent or ignore the effect of rolling resistance. That's this question. Okay. Again, before we solve the problem, this unit, week 4 units, we focus on impulse and momentum. With this one, impulse and momentum. A linear impulse momentum, also conservation of linear momentum, impact, angular impulse and momentum. That's what we talk about for this week, this handout exercises. Okay, so we're back to here and how to solve this one. We go to here. So first, so we have this guy's velocity equal to the velocity of the should be, so this velocity and minus relative speed. Relative is this velocity minus a velocity, but a is go to opposite direction. That's called minus VA equal to relative speed c with respect to a. Okay, equal to VC this direction, and the minus should be minus VA, but VA is opposite direction, so minus VAA, because you assume your direction is point to right hand side. Okay. So in this case, you get VC equal to VCA 2 meter per second, and minus VA. Get VC equal to minus VA, right? So, and then we know the momentum should be conservation. So MCVC, this momentum, should be equal to the MAVA. So MCVA's jump off should equal to MAVA. This is a momentum conservation. And then from this one, you solve VC equal to MA divided by MC multiplied VA. And then from here, we know that VC equal to this one, 2 minus VA. And they put here 2 minus replace the VC. And this one put here. And then you can move the VA and this side and take the VA out, common VA out. Then you should be get the VA as 1 plus MA MC bracket here divided over. So 2 divided by 1 plus MC, okay? And then multiply VC top and bottom, become 2 MC, and this one become MC plus MA, okay? So we know that MC is 70, MA is 80, and the 2 multiply 70, and then this one you cancel 70, you 270 you can cancel the 0, and you get 14 divided by 15 equal to 0.933 meter per second. Okay, this is VA. VC equal to 80 divided by MC is 70, and then multiplied VA. VA is this one, 14 divided by 15. Moved here, 40 by 15, and then you calculate this one, and you will simplify. You will get the 16 divided by 15 equal to 1.0667 meter per second. That's you get the VC and you get the VA. After you get the VC and the VA, and you already get the VA, then what happens for the VB? Okay, well, VB also the momental conservation. First, you go MCVC. The guy jumped over before jumped to MCVC. After jumped landing on the car B, and then MB have to, and the plus MC is one piece, and the total mass multiply VB after landing on the car B, jumped over. Okay, and this is the momental conservation. So MCVC equal to jumped over combined together MB plus MC multiply VB. And in this case, and then you can solve VB equal to this one divided by over MC, MB, MC. And this 70 plus 80 is 150. Okay, VC is this one, 16 divided by 15. And then you calculate this one, you get the 0.49778 meter per second. So you compare this VA and VB, compare your results. This VA 0.93, VA 0.93, VB 0.49, VB 0.49, 0.5, yeah. And what is VC? VC we get early before you get 1.067 equal to 1.07. Yeah, that's we get this result. All right. And it's clear for this question. Are there any question for this one? Can I move the next question? Is it clear? Because some student feedback I speak too quickly, but I ask you for this step. Do you understand any question for this one? So first of all, you have to study is VC, because relative speed is VC minus VA, but your VA is go the opposite direction. That's called minus VA. That's this tricky, okay? And the minus become plus, so that's why you get VC equal to VCA, and then move this VA over to minus VA, 2 minus VA. That's the tricky for that. All right, this momental balance conservation, MCVC equal to MAVA. Okay, and then you get VC divide MA divide, and replace this VC by this one, and you can solve this equation, solve the VA. You get the VA the result. After you know the VA, and then you can the VA, this can calculate VC, and then second momental conservation is so MCVC equal to after landing on the car C, MB plus MC together, and multiply VB. And from here, you calculate VB. This one divided by over, you know this mass, you know the VC already calculate, then you get the VA. That's why you get this, solve this VA, VB, VC. That's you solve this problem. Okay. I assume you have no question because you not raise your hand or have no any comments. So move to problem 3 if you have no questions. Okay, move to problem 3. What is problem 3? Problem 3 is the tugboat. Tugboat is a driving boat. Tugboat, driving boat. Okay, dynamic driving boat. And this driving boat has 19 megagram. Megagram is a 10.6 is a 10.6 power gram, which is 19,000 kilogram. Okay, it's tied to barge boat. Barge boat is driven boat. Okay, use that cable. So the driving boats pull this driven boat by a cable. Okay, and this barge boats have a mass of 75,000 kilogram. Okay, if the loop is elastic, have a stiffness of 6,000 kilonewton per meter, ask to determine maximum stretch in the loop during the initial tolling. If you can reach the maximum stretch, it means cannot stretch anymore. It means that these two balls move together. That's called maximum stretch. Okay, so first of all, before you reach maximum, they are separate move. They have their speed, this is another speed. So this tolling boats will be 15 kilometers per hour, and this driven boat and the barge boat at speed of 10 kilometers per hour. They are separate at different speed. Okay, this is at the beginning before you reach the maximum stretch. But after the reach maximum stretch cannot stretch anymore, which is these two balls move together. That's how this works. Okay, so first we have the momentum conservation, which is MT/VT, right? MB/VB. Okay, these two momentum should equal to, when they move together, is MT plus MB together and multiplied VB together, the speeds. Okay, combined speeds. So we just see this equation. So we have problem 3. First, we change this units in the SI units. Okay, multiply kilometer 1,000, hour, and divide by 3,600 becomes second. So you get this VT and VB speed. Okay, it's SI units. Okay, and we have the tugboat have a mass. Okay, use a megagram changing to 19,000 kilogram, and the barge boat 70 mg changing to 17,000 kilogram. Okay, SI units. Okay, then before you reach the maximum, the separate moving, this momentum is MTVT plus MBVB, separate momentum, sum together, and after they reach the maximum stretch, which is they move together, which is MT plus MB, and multiply with 2, they move together the speeds, which is V2. Okay, this is the momentum balance. Beginning the separate speed, they have a momentum. After stretched maximum, they move together speeds. Okay, then you can solve this equation, find the V2. V2 equal to this one divided by mass. So MT equal to you this put here, and VT is put here, this number, and MB put here number, and VB is put this number, put on, right? And MT plus MB, this plus together, get this one. So you calculate this one, you get the 3.05 meter per second, get the V2, right? This is called momentum conservation. Another one is energy have conservation. Okay, energy conservation. First, before they reach the maximum stretch, they have a kinematic energy, MT. This is the tugboat, half of mVt square. This is kinematic energy for the tugboat. And also kinematic energy of barge boat, half of mVb square. Okay, this total energy should be conservation. After they reach the maximum stretch, they move together. They have a kinematic energy of MT, MB, and multiply V2 square. That's the total kinematic energy. And don't forget, because this have a cable, have a stretch have a stiffness, then you have this spring have a potential energy of spring, because half K multiplied the deformation, the maximum deformation X. Okay, so this energy at the beginning, before you reach maximum stretch, they are pretty loose. Okay, they have they are not deformed at all. The cable is loose, so that's why they no potential energy at the beginning. After the fully stretch, and then they get the maximum deformation, maximum stretch, and then you include the kind of spring potential energy. and plus this kinematic energy of the move together kinematic energy. From this equation, you can solve this, move this term over. So this one minus this one, and then you can solve the x squared. So x squared and this cancel half, and divide the k over, and this is your numeric part, and this numerator and this denominator. Okay, so and then put this number mt and vt square and mb vb square, put number inside, and also mt plus mb together, and v2 we already calculated. V2, this one put here, divided by stiffness of a spring, and then you calculate this one, you get 0.236996 meter. We can check if correct or not correct. Equal to, you can type in equal 19000 multiply 4.166 square plus 75,000 multiply 2.777 and then minus 84,000. Okay, multiply 3.05 and square, and this brackets, this numerator, and divided by the k, which is 600,000. 600,000. So you can check this formula, make sure it's the same as what you're writing. Okay, and equal to this gets 0.01. Okay, interesting. So hold on, double check it's correct or not correct. 1.6 square, 75,000, 2.77. Okay, square. Okay, and the minus 84,000 multiply 3.05 square. Okay, 3.05 square. I think it's right. Divide this one. So this should be this 2 point, this one. So my calculation will be 0. So have a look what this result get. Result he gets his point. Yeah, get this one. Result 0.03. And this some maybe something not checked together. Have to try. Okay, this is 19,000 kilogram multiply 4.66 square. Okay, and plus 75,000 multiply 2.33 square minus 84,000 3.05 square. I think this may be so decibel, cause decibel error problem. So this be fine. Okay, so this result what I get before. Okay, to have the square root. Sorry, this is square. This is have the square root. This is x square. So in order to get x, should be equal to this one, sqrt. Okay, square root. And they equal. Hold on. This x square. Like that, x square, and hold on. Square roots. Sorry. This one equal to 9,000, 90,000 for 116 square plus 75,000, 2.33. 2.33 is correct. Minus 84,000. 84. I got to double check. It's 84 or not. It's 4. This 4. It's not 84. It's 94. Sorry. That's the reason. 94. Sorry. So I have to go back again. Since 94 is not 84, right? Plus together. That's cause the issue. Otherwise, it's not correct. Okay, go to here. And so you can check it out. Should be same. This should be 94,000. Hold on. So this one should be 94,000. Okay, and then give same, and then you have to calculate it again. So this one should be 94,000, not 84. And then this one should be get this one. This is your, and this is your x square, and then use square root equal to, because this x square equal to this one, right? And square root equal to 0.23. That's why you get 0.23. See that? 0.23. Yeah, it's fine. That's spelling mistake. I'm sorry about that. So this one, make sure it's correct. Otherwise, you won't get the same result. This 94,000. Okay. That's why you get this result. Be careful. This result, this should be equal to result. This is x square, and the square root get this one. That's why I get this x square and this square root get this result. Okay. So we move to next one, and this question 3 and question 4. Question 4 is a ball have a mass 10 kilogram and is attached to the end of the row. Okay, and whose mass? Okay, this law, the mass can be ignored or neglected. And if the shaft is subject to the torque, 2t squared plus 4, this torque, and t is in second, determine the speed of the ball when t equal to 2 seconds. That's very simple. You have m is moment, m d delta t, which is equals impulse, moment impulse, moment impulse. Moment impulse equal to the angular momentum changing. And at the beginning, okay, at the beginning they have at the beginning the ball have the speed. When t equal to 0, ball speed is 2 meter per second. So it's mv is the beginning. Multiply this distance, this angular momentum at the beginning, and then the ends after 2 seconds as m2, m times v2, and times this radius becomes second angular momentum. Okay, so get second angular momentum minus beginning angular momentum equal to m times t. That's how you solve this problem. So we go to this one. So we have m times t, okay, equal to the second times momentum multiply the radius, this angular momentum, and the minus at the beginning momentum multiply this r becomes angular momentum. This angular momentum change equal to mt. All right. So from here, we want to solve this m1. We know that we want to solve m2. Want to find what is v2. Okay. So here you can this one m delta t should be multiplied inside, and then move this r mv1 moved over. So m plus mv1 r equal to multiply together as mvr equal to this one. All right. So for m, you want to find the v2. So v2, then this v2 should be equal to all this one divided by mr. Okay, mr. So m put here, r you can put on the top, divide by r, and this r be cancel r. So equal to mtr mv1 divided by m. So this moments we know this function here, moments function is this one, we know that. For the this in the delta t this time, multiply this for delta t this individual, this time gets a moment impulse, and then you time your injury from 0 to 2 second integration. That's you get the moment impulse. Okay, moment impulse divided by r, and plus m is 10 kilogram divided by the beginning speed is 2. Right. So then you have to solve this one. So how to solve the integration for this one? This integration is easy. The first term integration 4, it becomes 4t, and the t square integration equal to t cubic divided by 3, and multiply 2, right? And then your integration from 0 to 2, right? From first term, t 2 to 0, 2 minus 0 equal to 2. 2 multiply 4 equal to 8, right? This is 8. Okay. And then the second one is 2 cubic become 8, and the 2 8, and the 2 times 8 is 16. Okay, 16. So 116 divide by 3. Okay, divide by 3. And this 16, and then 16, this 2 divided by 0.2 and equal to multiply both 2. 16 becomes 32, right? 32. And this one originally is 2 times 4 equal to 8. 8 times m's times 2 equal to 16. 16 plus 20 is 36. That's 36. Okay, 36, 32 divided by 3, and the sum together equal to 4.667. Okay, be very careful to this calculation. Be very careful. That's all. So this answer is 4.7. Our answer is 4.667. 4.7. So the tricky is to have to do this integration. Okay, this integration is 40, and this is cubic divided by 3, 2, and this is your integration. Say they have to calculate from 2 to 1 to calculation 2 to 1, and then you sum together equal this one and divided by this origin 10, you get this result. That's how tricky for this question. All right, do you have any question for this one? Can I move to the next one? Question 4. Do you have any question? If not, we have to move to question 5. Question 5 is 2 cars, A and B. Okay, so A driving in the A and B have the same mass, 2,000 kilogram. 2,000 kilogram, which is 2,000 kilogram. Yeah, it's a kind of 2 tons. Each of the cars 2 tons. Okay, that makes sense. Approximately the car or truck something 2 tons. Now usually it's 1 ton each car for passenger car. For truck it should be 2 tons. It's okay. So you have a car A driving the constant speed 15 meters per second. Go to horizontal, go there. And the B is driving from top to the bottom. They don't know this speed. We got to find this speed down. And they crash at this point, old point, have the crash. After crash, and you take after crash for car A, they will move in 40 degree this direction. Car B is 30 degree this direction. For car A, they after move 3 meters, they fully stop. That's you know that. And they give in this friction coefficient 0.15. Okay, and you assume the impact line is horizontal impact line. Okay, then determine car B velocity, and also determine the coefficient of restitution E. Okay, so this is the question. Then we come to solution. So first of all, we have to use the after car A crashed car B at the 45 degree. What if I take the 3 meter become fully stop, which means you have a friction. After that, after crash, you get the friction force. Friction force times the travel distance 3 meter, and this friction force will be consumed. After your impact have the speeds, kinematic energy consumed by this friction force. So that's why this after impact, this kinematic energy after impact, your velocity is VA2, and the kinematic energy will be half of m VA2. This energy should be consumed by the friction force. Friction force is mg times the friction coefficient multiplied force times distance. This is the walk, friction walk, and consume this kinematic energy. So from this relationship, and then because the first step, and this one should be equal to 0, and then from this relationship you can solve what is velocity VA2. Okay, you move this one equal to 0. Okay, move one this equal to 0, and then you should get cancel the m. You should get VA2 equal to square root 2 mu GSA. Right, this you'll get. And this is 3 meter, this is 9.8, this is 0.15, and this is 2, and the square root, you can get this is 2.96. Yet after impact, this speed will be 2.96. Okay, that's you get from this calculation. Then, and how can we get the VB at this speed? So we use the linear momentum conservation with x sigma f momentum in x direction to be conservation, and in y direction should be conservation. So we study the x direction first. For the before impact, okay, before impacts x direction, Ka A, you have m, Ka A, okay, it's 2 ton, right? 2 ton multiplied A is 15 meter per second. They have this here, okay. The car, this car B, the driving vertical direction, so x component equals 0 straight away, okay. And this before impact. After impact, then you have a car A have a speed which is 2.96, and then there's 40 degree this direction. So after impact is first start A first. A is m times and speed, m times speed, and then you have the projection in the horizontal direction. This one projection horizontal is sine 40. This one projection is horizontal is sine 40. That's for the car A and the x direction after impact. Okay, and then car B and car B VB after your impact, the speed we assume is VB2. We don't know. Okay, so mass times this VB2. This is a momentum after impact, and then projection to x direction cosine 30 degree, and this is a momentum conservation in x direction. And same thing for momentum conservation y direction. Before impact, y direction, this one only travel this direction without any y direction component. So this is equal to 0. And then this car move from top to bottom. It's opposite to a positive direction. So equal to minus mass times velocity. Okay, B1. B1, we don't know. We will find out what's B1 before impact, the speed. Okay. So the reason why it's negative, because this one travel from top to bottom, travel down. We have positives go up, we travel down. That's why it's minus 2000 mass times velocity. Okay, this is before impact. After impact, they have this car. This car we have speed like that. M times this VA, this momentum, cosine 45. Okay, cosine 45. This go pointing down is negatives, pointing down negative, minus 2000 times this speeds, and cosine 40 degree. Okay, and then for the car B is VB2. We don't know M VB2, but therefore the vertical component should sine 30 degree. Still move this direction, still point down. So still the minus 2000 M times VB2 and sine 30 degree. So you get these two equation. For these two equation, you look the first equation. You move this one, move it over. The positive become negative. From the right hand side, move to left hand side, and divide by 2000 and the cosine theta. You can calculate VB2. Put here, you can calculate 15.116. This one you can use the calculator to calculate. All right. So, and then after you get the VB2, and then we use this equation to find the VB1. So from here, so all this negative can cancel. 1 cancel. Then you get the VB1 equal to all this term divided by 2000. All this term divided by 2000. So equal to, and then should be, hold on, you can cancel this one, 2000 cancel 2000. That's why you get the VB1 equal to VB1 equal to VB2 sine 30 degree, and the plus 2.9698 cosine 40 degree. Okay, and then this one 2B2 equal to 15.116 sine 30 degree plus 2.9698 cosine 40 degree, and you can calculate 9.8 833. Okay, and that's you calculate the VB1, we get the result. VB2, we get this result. And then what is the coefficient of restitution according horizontal direction? According differentiation should be after impact VB x2 minus VA2 after impact x. Okay, and divided by before your impact VA x1 and the minus VB yx. VB yx, they have no horizontal component for the momentum before impact. So this one, that's why this one equals 0. We only have a horizontal component of a car, which is this speed VA1 we have the Dumbo, okay, and then VB2x after impact VB2x we already solved out here. We have VB, we know the VB is here, VB2 we know that, and then horizontal VB2 cosine 30 degree, VB2 cosine 30 get the horizontal components, okay. And then VA and this VA2x, which is VA this car, this speed hold on, this is VA2. We should solve VA2 is 2.96. We already know that. And this one horizontal components should be sine 40 here. So that's why you get this one. VB2 we already solved this one, and then VA2 is this one, and the cosine and sine. Okay, VA1 is we given this 15 meter per second, and you put this number inside, and you can calculate. And this is a coefficient of this reinstitution equal to 0.7445. I can give you some example how to calculate. It should be double check. Okay, so for this one, you should understand VB2 from this equation. Move this item, move over. You can cancel make it easy. You can cancel this. Hold on, your VB2 from here. VB2 should be, you can cancel this one. 2000 cancel. So you get VB2 should be move over, should be equal to hold on, this one. I did not cancel. And should use this one is also okay. I use without cancel. That's fine. So use this formula. Type in this formula equal to bracket 30,000 and the minus 2,000. Okay, multiply 2.968. Okay, multiply sine 40 degree. Be careful, all this sine inside it should be typed radial. Radial, not angle. If the angle you convert angle degree into the radial, how can we do that? Convert the degree to the radial. You have to use the 40 multiply the pi divided by 180. Then you make a conversion, change the 40 degree and to the radial inside. Then you can do this calculation. Okay, and then bracket again, divide by 2000 and then multiply and cosine. Again, the 30 degree you have to become the radials, become radial. Okay, so it multiply pi divided by 180, and then you can get a cosine. Okay, this one enter. Hold on, just equal to, so equal to 30,000 2.9698 sine pi divided this one, sine pi divides this one. Okay, sine pi and divide by 2000 cosine 30 degree multiply pi divide this two, right? So this one should be give you 11. Hold on, 11. We double check. Okay, maybe what is the result I get? Hold on a second. What the result I get here? What's the result? 1506. VB 1506. I think my calculation is right. Looks like so. Okay. So why we not get these results? Be very careful. So we can also do that without take off the 2000. So takes to 2000, this should be 15, right? Equal to 15. 15 minus 2.9698 and multiply and the sine, hold on, multiply this should be moved over to sine 40, right? Sine 40 and multiply pi, yeah, divided by 180. This minus, okay, and the brackets divided by 2000 already gone. Divide the cosine is should be cosine 30 degree, right? Yes, 30 degree. 30 degree. And the p pi. And divided by 180. That's how you calculate. All right. And this one, how much you get? Okay, this one, 15.1. So I think this is correct. As this one, something wrong. What's wrong? For 30,000. 30,000 looks okay. 30,000. And minus 2,000, 2,6, it looks okay. Sine, cosine, pi divide this one. Okay, looks like divide by 2,000. Okay, that's the reason. You have to make brackets. Otherwise, they don't like you. And look here. It's accent. So you miss the bracket. Be very careful. After bracket, you get the same. Okay, the same thing. You can cancel this 2,000. Make simplified to calculation, or you can to do that. Okay, the same thing for this one. For VP2, you already cancel the 2,000. Cancel the minus 2,000. That's why VP1 you get a simple like that. And put this one, you can calculate, check its calculations right or not. So equal to, again, equal to, be very careful. So equal to this one, multiply sine, right? By sine 30 degree, degree become radial. Pi in the Excel use pi brackets 180, 80, okay. Sine and the plus 2.9698 multiply cosine. Cosine should be 40 degree, right? 40 multiply pi divided by 180. And this is your result, should be result, okay? And then you enter, you get 9.833. You get straight away. So very simple, right? So be very careful when you do this calculation. Make sure you make brackets. Otherwise, without brackets, this way will divide 2,000 multiplied from here. That's the reason. Make sure you make brackets. Be very careful. And for this calculation, you put inside, you calculate, double check. So if this calculation we have double check is equal to, and this one, this is your calculate VB2, right? And multiply cosine, sine, and 30 degree, and pi divided by 180, right? Okay, minus 2.9698, right? Multiply sine 40. Be careful, this degree have to become radial. Multiply pi, okay, divided by 180. And okay, this is a sine, okay? And then this one have the bracket again. This is numeric divided by dominates 15. And this is your final result, 0.745473. Okay, you check your results. Okay, so this is a point and result did not give the result for the but VB1 9.73, VB1 9.73, 9.833, I guess 9.833, 9.83. Yeah, that's right. VB2 is 15.116. VB2 50.06. I get 15.116. Little bit difference. Okay, little bit difference. And then because decimal, calculate decimal, and then VB A2 2.997 and what I get 2.969. We get the same results. Okay, that's how you do this calculation. So principle for this one, you have to use a momental conservation in the x direction. Okay, before impact momental x direction, after impact momental in x direction. So in y direction, before impact y direction momental, and after impact y direction momental, they should be equal to each other. Okay, then you get a two equation, and from these two equations you can solve and the VB1 and the VB2, VB1 and the VB2, right? And also for the VA2, how can we solve? VA2, because after impact, you get velocity. This velocity, kinematic energy, will be consumed by friction work. So this friction force times the distance, friction work, equal to the consume this kinds of kinematic energy. And then you solve this from this equation, you solve this VA2 after impact, this speed. That's how you get from. Okay. After you get the VA1, VA2, and this equation, you have the VA2 here, and then you can solve the VB2, right? So you have VB2 and the VB1, and then you use definition for the x direction, the coefficient of restitution, the definition, and you can calculate the Ex equal to 0.74. That's how this problem solved. Okay. First, you find from the friction work consume the kinematic energy, find the VA2. Second one, you use horizontal direction and the vertical direction. Before impact, after impact, the momentum should be equal to each other. And to get the two equations, you solve the VB1 and VB2. That's how to solve this problem. Okay, move to the next problem. Number 5. Number 6. Number 6 is 2 kilogram. Is through at the suspended 20 kilogram. The block. The ball is 2 kilogram. Impact ball is 20 kilogram. And with the speed 4 meters per second, this speed. Okay. If time of the impact between the ball and the block is 0.005, okay, and determine average normal force exists on the block during this time. Okay. Also, we assume E horizontal direction, the coefficient of restitution E equal to 0.8. That's assumed, right? So how to solve this problem? Because we have to use the definition. Well, what definition for the coefficient of restitution? Okay, and then we start from here. So we go to next question. So definition is after impact, block 2 horizontal velocity minus the ball after impact velocity divided by ball and horizontal velocity minus the before impact block velocity, which is equal to 0. And this one equal to 0.8. And from here, after impact, the velocity we don't know, and ball we don't know. They have 2 know, and the multiply here 3.2. Then you get one equation is ball the block minus ball equal to 3.2, and then you solve the v ball equal to v block minus hold on, v ball equal to v block minus 3.2. This equation. Okay, this from this definition of coefficient of restitution. The second one, we get momental balance before impact MV. MV, you only before impact the block equal to 0, so no moment of block. Only have ball. Ball is m times velocity. Okay, so before impact. After impact, then both ball and the block have velocity. So ball have 2 times velocity, block have 20 times velocity. So then you have this unknown, this unknown. So you have one equation and 2 equation, 2 unknown, and then you should be able to solve this 2 unknown, 2 equation. Solve what is solve out what is block 2 and what's ball 2, what is velocity. Very simply, you can do this way. You know that this one from this equation, we from here we get this equation, and you move this equation from top to move down, and you replace this ball velocity 2. Use this one, replace. So this 2 multiplied 4 is here. This v ball replaced by this one, and plus 20. And this multiply 2 V ball plus 20 V ball is 22 V ball, right? This minus multiply this 3.2 becomes 6.4. It's minus move over 6.4 plus 8. That's the right hand side. Get 14.4. And then you can solve V block 2x divided by 14.4 divided by 22 equal to 0.64. And that's your result. And after you get the V block 2x and use this formula, this is 0.6654 minus 32. You can get a ball velocity. V ball to x velocity equal to this one minus this one equal to minus 2.54. This velocity. Okay. And then you want to get the force. You have to use the impulse of the, if you impact in the block, impulse equal to the momentum changing, which is m2 m times v block 2 minus m block v block 1. V block equals 0. Okay, this equals 0. So that's why you time how much second? 0.05 second. Okay, and this block mass is 20. Block v block 2x, we calculate 2x is this one 0.654, and this one calculates, you get this force will be 2,618. This force will act on this block, this force, impact force act on this block. In the same way, if we study this ball have F times force times delta t. To study ball, so after impact ball momentum, m ball and v b ball to x minus before impact m ball multiplied v b ball 1x, and this one, and then you get the force should be this one divided by delta t. So m ball is 2, okay, and the first vb2x we already calculated is equal to minus 2.54, okay, and the ball and then should be minus ball, and also there's another one is ball 1x. Ball 1x, I think hold on, I think something I do not do correctly. Hold on, this one should be ball 2 to take come out. So the ball 2x is minus this one. This is the ball 2x. Ball 1x. 1x should be 2. Sorry, I think this one you have to make sure is correct. Hold on a second. This one, and so this one, you can see that this one you have so this one you study ball, all right. So this one equal to the ball. So this is 2 times this m2x here, and the minus ball 2 times at the beginning is 4 meters per second, right? And then this one calculation and divide the 0.04, you get the minus 2,618. Because action reaction, this gets opposite the sign. Okay, and also if you get the energy after you impact block, get the velocity v2x, which is v2x is 0.6545 meter per second, and this one creates kinematic energy of the block. Kinematic, this can be converted to the potential energy, which is m block gh, energy conservation, and then you can calculate the block can be moved how high. The height equal to is equal to this cancel to the m equal to velocity squared divided by g equal to 0.0218 meter, and that's the result. Yeah. Okay, that's the result. I think this is because this block here. So, hold on, I think this one, this block. That's the reason. Okay, the block is the graphic formula. That's why I say it's very strange. Move up a little bit. Okay, that's better. Okay, that's the correct result. And this is, you can find what is force. Force is minus positive 2,618 on the block. For the ball, it's minus 2,818 on the ball. The action reaction, and we also calculate the the block can move how high. This edge should equal to 0.021859. Okay, this is not asked by question, but we do it. Okay, question also only asks what is the force. What's the force they get? Force is 2640. What do we get? 2618. Little bit change. 2620. Little bit 26440. Right? 2640. We have little bit difference. 2640. What do I get? 2618. Yeah. And also for another one is 0.0, H is 0.022. And what do I get? 0.01822. Approximately same. Okay. Then we have we have the 10 minutes break. Okay, continue.
is one of Australia's most loved animals. With its big fluffy ears and black button nose, it's adored by all. Though cute, koalas are thought to be lazy and slow on the uptake. But once you scratch the surface, there's much more to their world than meets the eye. Communication, conflict, and even deception occur inside the usually secret world of a koala colony. With that world becoming ever more fragmented from urban encroachment, it's a society that is now under threat. 200 years ago, millions of koalas lived across Australia's eucalypt forests. The koala is one of Australia's most loved animals. Crosses every extreme of a They're the brightest cast of characters in the Australian story. A routine to find. They try to outwit each other. Call them out, playing under them. I think I'm complicated so don't get it. Rowdy and resourceful. They're Australian originals. They're parrots in the land of Oz.
Okay, we have to back to our lecture. Okay, so next one we talk to week 5 tutorial. The question 1, this one gear, there is him to push this gear clockwise and this anti-clockwise. This S gear will be moved. Then push this one. If move this one, the push this go up to make this Windows winner to watch the screen. So mechanism for the car windows wider is shown in the figure. Here the handle turn the small gear C, okay, and then which rotates spare gear. Which rotates spare gear S. So you move this one, spare gear will be anti-clockwise and push the A go up. Okay, and then drive this lever AB lever, push it anti-clockwise. This should go this direction, anti-clockwise, and then which is raise this chuck D, raise the chuck D. Okay, so this chuck raised up. How this works? Okay, in which Windows rest. Okay, this is a wiper, and the window is free to slide on the chuck. If handle, this radio is 0.5 omega equal to 0.5. Determine speed of A, which is this direction, A speed, and also E. A and E should be same, right? And speeds VW, which is D. So what the relation angle? This V is vertical, and A is the degree. This if this is 30 degree, and this degree is how much degree? This theta. If this is theta is 30 degree. Okay, 30 degree, and this should be 30 degree here. Be very careful. This A is this speed 30 degree, and this is vertical. So how can we solve this problem? First, the gear mesh type formula. We go to start gear mesh. RC and RS. They have to tangential speed should be equal to each other. From here, this one you can solve what is omega s, RC divided by RS omega C. And then you got this radio and you get the omega, you get the omega s. After you get the omega s, and then this O omega, we know that, and then the A points, the speed should be tangential speed, right? This speed equal to radio, this distance 0.2, right? 0.2 times omega. So 0.2 times omega is 0.2, is 0.04. Then you get this point speed and this point is same. But this angle is 30 degree, and this speed should be 0.034, 0.04, right? And then if you find the VW, then this speed component to vertical component cosine 30 degree, and then multiply 0.04, you can 0.034 meter per second. And that's, you solve this problem. Any question about this one? Is all? It's very simple, straight away. Okay, so we move to question 2. Question 2 is, again, it's very simple. You have a gear A matched with gear C, and gear C, omega C equal to omega D, and gear D is matched with gear E, and gear E, omega rotation speed equal to gear F. Gear F matched with gear B, okay, and gear B is output. You give in the omega A, ask you find what is omega B. Very simple, this one. Okay, so how can we solve this problem? So we go to start for every paired mesh. We can see that for the gear A mesh with gear C, then we have the mesh formula RA omega A equal to RC omega C. And we know omega C, omega D equal to each other. And then you solve the omega C to equal to RA divided by RC, RA divided by RC multiply omega A. Okay, but this is omega C equal to omega D. So omega D equal to this one, equal to this one. All right, because omega C equal to omega D, so omega D equal to this one. Then we get to second gear mesh, pair gear mesh, and D and E mesh. D and E mesh use mesh formula RD omega D equal to RE omega E. Then you can solve the omega E. So omega E is RD divided by RE times omega D. This is omega E. But omega E equal to omega F. So you replace omega E by omega F. This one, second equation like that. And to get the last pair of gear mesh is this gear mesh, B and F mesh. B and F mesh. We can go to B and F mesh. We get to RF omega F, RB omega B. And you solve what is omega B equal to RF, RB multiply omega F. Okay, and then we want to solve the omega B, so use this formula first. And this one already we know that, but what's omega F? Omega F use this replace. Omega F use this RD, become RD here. But RD is what? RD is this one. Replace RD by this one, RA, RC, and omega A. That's why you get omega B equal to this one relates omega A. And this ratio, we know that, put the number inside, and this omega A equals 40, and you multiply, you get results 89.6 radio per second. That's very straight away. So you put gear mesh, put pair meshed gear, put the formula, and put this equal formula inside. You can straight away get the results. Very simple. All right, then we go to problem 3. Problem 3 is this is a vertical axis windmill consists of 2 braids, and that have a parabolic shape. If braids are originally at rest, and then they begin to turn with a constant angle acceleration, spin up. Determine magnitudes of velocity and acceleration point A and point B on the braids after the braids have a rotation through the 2 revolution, after rotate 2 revolution. Okay, how can we solve this issue? So this is a constant accelerates, okay? Constant accelerates, and the accelerates, you know the distance, you know acceleration, the distance. You should be find what is and for the formula, you should, for formula, if you go back to your formula, you should reference. Formula is here, reference your formula. And you should always use this one. You know the S, two revolution, okay? You know the A, you should find, at the beginning is 0, you should find the velocity. So come here. And we can use S, use the displacement formula. Is theta S equal to half of theta dot dt square, which is this formula. Use use this formula, t equal to 0, S equal to half of a t square. Use this formula. Fine. Okay, so it's this formula. And we know we find the t, rotation the t, so square root 2 theta divided by theta. Theta dot, we know that. And the theta 2 revolution is 4 pi. Yeah, 4 pi. 1 revolution is 2 pi. 2 revolution, 4 pi. 4 pi times 2 equals 8 pi. Divided by this acceleration is 0.5 square root 7 seconds. So this is from this 7 second, 2 revolution will take 7 seconds. And then you find the omega. Omega equals theta dot equal to theta dot multiply the t, right? And put this t, put it inside 7 multiply 0.5 and equal to 3.5. This is omega. After you get omega, and the VA speed equal to radius of A. The radius of A is given here. A radius is 2, right? 2 radius, A is radius 2. So it's 2 times this omega. You get the tangential velocity. After you get the tangential velocity, and also we know theta dot is 2. R theta dot, you get the tangential acceleration. 2 times 0.5 equal to 1. Okay, and we also get the central pedal acceleration equals R theta dot square, omega square. Okay, and this is R is 2 multiply theta dot is 3.54 square, and multiply together you get AR, radial components of acceleration, and this tangential components. So you get the total acceleration equal to this square plus this square root equal 25.125. Okay, this is for A point. For B point, the same scenario. The radial times omega become tangential component of velocity, which is 1. This is B point is 1, radius 1. B point is radius 1. So 1 times omega, we get 3.54. Get 3.14 tangential, this speed, point tangential speed. And then you know the omega dot dot, which is acceleration, angle acceleration, times the radial is 1, and you get this is a tangential acceleration, 0.5. Okay, for the B points. Okay, and for the radial direction component equal to R omega square, and R is 1, omega is 3.54 square, and they multiply together, you get 12.5. This is a radial direction component. This is tangential component. So total, the B point acceleration is this square plus this square root, and you get 12.57 meter per second square. And that's this answer. So one is get 12.54 B point, and A point is 25. 12, 25. So 25, 12. Look. 25 and 12. Yeah. 25, 12. And the speeds VA7, 3.5. VA7 and 3.5. We match the results. Okay. 3.5. 7 and B is 3.5. Yeah, match the results. Okay. So we move to the next question. Is this have a gear A is matched with gear B. A gear is called drive shaft, drive gear, and this is propeller gear. B is propeller gear. Okay, so he said the gear A on the drive shaft of the outboard motor have a radius of 12.5 millimeter, and the mesh pinion gear B on the propeller shaft has a radius of 30 millimeter. Determine the angular velocity of propeller in the t equal to 0.5 seconds. Okay, and if the drive shaft rotate with an angle acceleration alpha equal to 400 t cubic, where t is in seconds. The propeller is originally at rest, start from the rest, and then do acceleration. The motor frame does not move, assume. Okay, how to solve this problem? So we use this one from here first. This is your angular velocity of driving shaft. But we know there are two gear mesh. Mesh have a formula. Okay, we start from mesh formula. Mesh formula is so we have for a drive shaft, the angular velocity is 400 t cubic. But this two gears mesh, which is mesh means you have a RB multiply theta B equal to RA theta A, and two differential two times, which is R theta dot dot, RB theta dot dot, and RA theta dot dot. They should be same because it's just differential both sides two times together. So RA we know, RB we know, theta A equals this one. So then you put this one inside and put this one inside. Then you get the theta B angle acceleration equal to this one. Okay, and then because theta angle acceleration equal to d theta dot d theta, do one integration from 0 to t. One integration for this one integration 3 means 4 t4 divided by 4. This divided by t4. Okay, t4, and then your integration from the 1.5 seconds. 1.5 seconds, so make 1.5 inside and calculate this one equal 210.9 meter per second. This is omega. This is propeller shaft. The rotation speed equal to 210.9. And what's 211? You get 211. I get 210.9, 211, approximately 211. That's for this question. For how to solve this question, key is use the mesh relationship, and use originally acceleration function put inside. Do two integration, you can get your omega. That's the key for solve this issue. Okay, so this one we finish the question week 5. Then we have to move to the week. Hold on. This one should be go to the Singapore. Yeah, okay. To this is we finish. Okay, this is 6 finish. Week 7. 7. This one. 7. Also very simple. We can quickly go through. 7, we go to 7 and this solution. Okay, how can we solve 7? For this one, question 1 is you have this mechanism. RAB have a angular velocity anticlockwise, omega AB equal to 6 radial, and have to determine block C, their velocity. Okay, at the instant, this is a 45 degree, 30 degree, this instant. For this kinds of problem, first of all, you have to determine the rotation center. So rotation center, usually you have to determine by 2 velocity line. So center should be, rotation center should be perpendicular to the velocity line. For example, here, AB, you rotation anti-clockwise. So anti-clockwise, make a line, this is tangential velocity. So B, velocity, tangential velocity, okay? For this direction. This is for this AB bar. But for BC bar, the same velocity like that. So this velocity like that, you can make this one perpendicular to this velocity, this point, which is extend AB, this line. So your rotation center of BC should be in this line, extension of AB. And the same thing, because this move and the horizontal, so this the perpendicular to the moving, the tangential velocity should be the vertical line. So this should be vertical line. Rotation center should be in this vertical line. And the rotation in this line and also in this line, cross section, this is rotation center. You find the rotation center. So we first find what's the rotation center. So extend this line here and extend this line here. You find the cross section, that's your rotation center, D. Okay, so in order to find this the velocity, you have to know this omega. If you know the omega, multiply the dcd, and then you get the velocity. Very simple. Okay, that's you want to solve the velocity, and also you can get the velocity. Okay, so we start here. So solve the problem. We get this line, get the rotation center. We can start first. So we get BF divided by BC equal cosine 30 degrees. So BF equal to BC times cosine 30 degrees. That's clear, right? And also BF divided by BD, because this is an angle, this parallel, this 45 degree, this 45 degree. So that's why BF divided BD equal to cosine 45. Okay, then we have get the BD equal to, the cosine is square root 2 divided by 2. So BD over swap over, then this BD equal to BF times square root 2, right? And then BF is this one, put it inside. Then this BD, you get the BD is this amount, okay? And then move this one cross over, okay? Move cross over, and then we in order to find the omega BC, okay, we have to use the because this BC rotation along this D points. So in order to find this omega, you should know this speeds. This VB divided by BD. That's your omega. So equal to VB divided by BD. This is your omega. So VB, B is the end point of this AB bar. This B velocity equal to AB multiplied radius multiplied the omega AB. So equal to omega AB times AB. You get the VB velocity. And the BD, we know this one. Put this one inside. And then you put the old number inside, you calculate equal to 1.95. You get the omega of BC, 1.95. After you get the omega BC, and then omega times, because this is your rotation center. This is your rotation center. Okay, omega times this radial, CD radial. Okay, omega times CD radial, and that's the C point velocity. And then omega CD, BC is the same. Omega CD rotation here, omega BC is same. All the rotation center is D. And then this CD multiplied theta dot BC. CD equal to how much? CD equal to this one. DF. DF equal to BF. Okay, so equal to BF or DF plus this n equal to DF plus FC. DF equal to BF, so equal to BF plus FC. So BF is what? BF is this one. BF is this BC cosine 30 degrees. BF. What is this one? This one is BC, half of BC. Because this 30 degree, half of BC. So you write here is half of BC plus BF. And BF, we already know is this one. BF already know is this one. So you take the BC out, it's 0.5. And inside is 0.5 plus cosine is 30 degree. Multiply theta dot BC, 1.95. And calculate together is 1.33. Get the VC, this velocity. That's how you get this one. Right. So very quick and very simple. 1.32. What do I get? 1.3233 approximately. Okay. Then we move to second question. Second question very similar. The same thing. The CD have a omega rotation anti-clockwise. Okay. And also you have to determine point E velocity and the angle with velocity of AB. The same thing for this kind of thing, you have to find the rotation center. First of all, you know this omega, you know C point velocity go to this point, go to horizontal point to from right to left. Okay, for C velocity. So then you extend this line. This is your rotation center of BC. Should be stay this line. Okay, and also we know B, this AB, you move you move this way, you push AB also is anti-clockwise. So B velocity must be go this way. Okay, go this way. And then you extend AB, rotation center should be stay in the AB extension. The AB extension and the BC extension cross-section, this is your rotation center for BC. That's why I find the rotation center first. So that's why I go to rotation center, this extension, and this extension cross-section. That's cross-section rotation center for BC. So after you get the rotation center, and then you should find the omega. If you know the omega multiplied Fe, then you get the E velocity. All right. And then if you know this velocity and divide by this AB, you get the omega of this omega. So now it's simple. So how can we get that? So first of all, you use the BC divided by BF. BC divided by BF cosine 30 degree. Right? And then we know that BF. Okay, so then we solve the BF equal to BC divided by cosine 30 degree. BC is 0.2, 0.6. BC is 0.6 divided by cosine 30 degree equal to 0.69. You can solve the BF. And this you already know that. Okay. And also FC divided by BC. F3 divided by BC tangent is 30 degree. This 30 degree, right? This 30 degree. Why? Because this angle equal to this angle. This parallel. It's 30 degree, this 30 degree. So tangent is 30 degree equal to this one divided by this one. FC divided by BC. Tangent is 30 degree. Okay. And you know that BC is 0.6. And you can find what is FC. FC equal to BC multiplied tangent 30 degree. BC is 0.6, tangent 30 degree, and multiply equal to 0.346. And you find what is FC. You find FC. And you find the BF, you find FC. Okay, next one, you want to find what is the FE. What is FE? So FE is, you know this EC is half 0.3. You know FC. So this square plus this square root is FE. So you can find FE. So FE C square plus FC square. FC square is 0.36, 0.34 square. CE is half of is 0.3, and you just calculate equal to 0.45. Get FE 0.45, and then you want to get omega CD. This CD times omega, you get the C point velocity. C point velocity, and then you divide by the radial rotation center radial FC. Okay, equal to VC. VC equal to FC times omega BC. All right, and FC we already calculate 0.34, and omega BC, and then from here, and then you can calculate the omega BC equal to the 0.6. Okay, multiply the 6 divided by this radial. Get the omega BC, right? So this one, CD, we know that CD is 0.6, right? And the omega CD, we know that is 6. Okay, 6. And this one, omega BC equal to this one divided by FC. FC we already calculate 0.346. And then you can calculate, you get the omega BC, equal 10.339. All right. And then after you get the omega BC, and then you calculate BC, the rotation omega, get this speed should equal to FE times omega BC. For the VE, the EF times omega BC. Omega BC 10.36. EF will recalculate 0.458, multiply it with 4.76. That's VE. Okay. After you get VE, this is your VE. And then how can we calculate the omega AB? So, and then we have the B points velocity equal to omega BC multiplied the BF, right? So we get BF times omega B equal to VB. BF we already calculated before equal to 0.69. Omega BC we already calculated here 10.39. And then you multiply together, you get 7.2. This is VB. You calculate VB, this VB velocity. You know VB velocity divided by AB radial, you get AB omega, get omega AB. So omega AB equal to VB divided by AB, which is AB is here. AB is what? This 30 degree, AB is twice of this one, twice of CD. CD is 0.6, twice of CB is 1.2. That's why you get 1.2 here. And this same 0.2 is VB here, divided by 6. So you get omega AB equal to 6 radian per second. Okay, that's how to solve this this question 2. Question 2. The key for this one, find the rotation center. From this one, extension line, find the rotation center. From this geometry, you can calculate what is BF, what is FE. After you get, and then also from this point velocity, this radial and this omega, find this point velocity. Divide by this radial, you get omega. And this omega multiply this radial, you get this velocity. Okay. And also from this omega, this radial, you get this velocity. This velocity divided by this radial, you get omega, this omega AB. That's how to solve this issue. Then we could question 3. Question 3 is this one. This given the instance, slide the A block A, there we have velocity this direction, but the deceleration go to this direction. Okay, and then determine acceleration block B, and also angular acceleration of the link, angular link in this instance. Okay, how can solve this problem? So we come out again this rotation center. This speeds like that because the speed must be vertical. So there's particular this vertical speed is this line. Particular this vertical speed is this line. Cosection this rotation center. Find rotation center first. So we go to second question. We go to this one, perpendicular this velocity, particular this rotation center. Okay. So we assume this is vertical is positive. This one is positive. Okay. Then we can go from this rotation center. We know this 45 degree. 45 degree. This is 45. So this one should be equal to this one. So we can go to AB, AC equal to BC. AC equal to BC equal to the, because this 45 degree equal to AB cosine 45. So equal to AB cosine 45 is square root 2 divided by 2, or 1 of the square root, same thing. So you can calculate the AC, BC from AB. AB is 0.3, right? You calculate 0.212. You can calculate AC, the BC, which is radial. Rotation center, that's radial. Okay. After you calculate AC and BC, and then we calculate, we know the VA divided by this radial become omega, right? So VA and omega equal VA divided by AC. VA is 1.5 divided by radial AC equal to 0.212, and then you get 7.007. This is your omega of this AB omega. This AB omega multiply this radial, you get a B tangential B velocity. Tangential B velocity. So this one, so we get first of all we get A. Before we go to B, we go to A. We have a tangential velocity and equal to radial R omega square, and they get tangential component of the acceleration for A points. And the tangential also we have a this is a radial component. Also we have tangential component, and tangential component already given, so minus 16. So minus 16 because this direction positive, this negative, minus 16. So you have A point, you have radial components, you have a tangential component. This square plus this square root, you can get A point acceleration. Okay, then we know these points have a deceleration 16. See, 16 divided by this radial AC, you get angular acceleration. Angular acceleration is c dot AB. You could AA divided by AC, 16 divided by 0.212, and you get 75.442. That's omega AB dot. Okay, and this is angle acceleration because all this bar angle acceleration should be same. So then you get from you know angular acceleration, multiply this radio, then you get the b direction tangential acceleration. So b, then you get the bc times this c dot dot and equal to 16. You get the b tangential acceleration component 16. Okay, and also we know that omega ab 7 multiply bc, the point b acceleration equal to radial times omega equal to tangential velocity, which is minus 1.5. Okay, you know this tangential velocity v square, and you should be get the radial component is r omega square. This radial is 0.212, and omega ab we know before 7.7. Then you get called the central pedal acceleration 10.66. This is radial components. Okay, and then the tangential component is 16. So this square plus this square root, you get 19.19. And this is so b direction acceleration. This 8.8 sum of the acceleration. And then we know the total bar AB angular acceleration should be 75.42, which we calculated before. This one 75.42. That's how solve this problem. Okay. So again, with summary for this question, you have to find the rotation center. From rotations from this velocity, you can find the omega. From this omega, you find another tangential the speed of the b points. You know the tangential speed and the v square divided by r, or r omega square, you can get the radial component acceleration. And then also for the tangential acceleration should be equal to angular acceleration multiply the radial. So then you have a tangential acceleration component, the radial component, this square plus this square root, you get the sum of the acceleration. Same thing here, you have a tangential component 16, and also you have v squared or v squared divided by r, or r omega square, get the radial direction component. This square plus this square root, you get the total acceleration of this point. That's how I solve this problem. Okay. Then we move to the next question. This truck, and put this and at time instant, the truck is moving to the right at 3 meters per second, while the pipe is rolling to omega equals 16 radians per second without slipping at the point B. Ask determine the speed of a pipe center at G. Okay, how to solve this problem? So this one, we go to, we assume this is the positive direction. Okay, the truck is moving 3 meters per second, but this roller, or this roller, if we move in this direction without slip, so then we can see that Vg absolute velocity equal to their base is truck is 3 meters per second. Okay, but this with anti-clockwise, they move another direction. This opposite is positive, should be negative, minus r omega. R omega, this instantaneous, this rotation center is here. R omega, this is your velocity, relative velocity. So 3 minus r omega. So 3 minus 6 times omega equals to minus 6. That's why you get your absolute velocity of center of this roller, and this minus go to opposite of the positive direction, equal to minus 6. That's how to solve this problem. The last one is the bicycle moving the 1 meter per second, move the positive direction. However, the bicycle have another wheel, and with rolling wheel. And these points, okay, ideally, if this point without slip, so ideally they have pure load, which is this rotation center. So this one, rotation center, this omega multiply this radial, then give this speed. Without slip, this speed r omega should be equal to this one. And then with speed and this have difference. So they equal to 1 minus r times omega, and you give your slip speed. So we can straight away equal to 1 minus radial r multiply omega. That's your slipping speed. Point equal to minus 0.95. Let's go to another direction, negative direction. That slip speed go to this direction. So ideally, without slip, this one should be equal to R omega equal to this one. But because of slip, they are different. So the difference equal to 1 minus R omega. That's you get slip speed. That's how I solve this problem. Very quick. And you can see that's this result. Results will be 0.95. But my result is 0.95. He point this direction, so opposite to the bike direction. The sense. Okay, then we go to week 8. Okay, week 8. Week 8, we open the week 8. And also the week 8 is very simple to solve. Okay, so first one, this is the rectangular plate. Dig the hole in the middle. Okay, and hand up in the O position. Ask you calculate the rotation of initial of this structure. Assume this thickness of this plate will be 50 millimeter. Okay, and the density of material is 50 kilogram cubic meter. Okay, so how we solve this problem? So this problem is we have so rotation initial of IO point equal to the solid plane rotation initial minus this is this minus this kind of cylindrical plane. You minus take it out because you remove this material. So this is this cylindric plane, cylindric rotation initial, and you solids minus the cylinder initial. You got this structure rotation initial. Okay, and then for solids, they have two parts. One part solid is with central gravity rotation initial, and plus the mass center, gravity center, m times this distance. We assume this to here distance equal to b, mb square. All right, and for this one, for this removed material, cylinder material, this cylinder material equal to the gravity center I rotation initial plus this mass m2, this mass multiply the distance mb square because it take it out minus. That's why how do you calculate? And then define what is m1, m2, what is SPO, and what is SPG, and what's CPO and CPG. That's definition. Okay. Then how do we solve this problem? Then we have for the plane, the solid plane, we have go to one horizontal direction. Rotation initial equal to ML is L, MA square 1/12. But you want to do that, this is 1/12 and then another 1/12. Then you make the vertical direction rotation initial to be double of the 1/12, 2 of 1/12. You get the rotation initial of the solid plane in the middle, vertical axis. Okay, this is that's for the first part. The second part, you can move this one over because this one, you move this M1, M2 minus M2 together. This is minus M1 minus M2B. So this will put one minus B. And then minus ICP plane. This ICP plane is a solid plane, cylinder material is half of M2 R square. Okay, this stick out. So this formula become this formula. And then you put the M1. So this become 1/12, become 1/6. M1 equal to the A times A, 1.4 times A, 1.4, 1.1 times for this area. Multiply thickness 0.05 thickness times the mass density. Okay, this MEM, and multiply the side length 1.4, and this for this one. Okay, and then M1 is the solid mass. Okay, square plane mass, and then this part is the cylindrical cut-off cylindrical material, the mass equal to pi r square multiply thickness cylindrical volume multiply stiffness becomes m2, right? M1 minus m2, and this b square. How can you calculate b square? B square is this to this distance, A B square is very simple, and you equal to this one, equal to this one, 1.4, okay? 1.4 divided by square root 2, okay? This cosine 45 degree equal to sorry, this should be, so this one, square root 2 multiplied this one equal to this one, and divide by 2, you get a B. So it should equal to, and should be equal to this one. So you square root 2, okay, 1.4 square root 2 and divide by 2, and a square, make a square, and equal to B. So the B, so this B equal half of this one. And this one equal to 1.4 times square root 2, and make a square. Square root 2, get rid of square root, become 2. And 1.4 become 1.4 square. 1.4 square, okay? 1.4 square, 2. And then you have to divide by 2. Divide by 2, and the square become 2, 2 and 2 square become 4. And that's why you get the B is like that. B square is this one. And then another one is B2. This you take this one over, this mass over, and the multiply radius is 0.15. Radius is 0.15. Radius is 0.15. Yeah, radius. And this calculates, and they get results 0.227 kilogram meter square. Okay, that's how you calculate solve this issue. And then we next one calculate the rotation initial of this structure. This structure, we get this item, rotation central of this axis, rotation initial equal to this bar, 12 mc and L square. This is bar. And also equal to, and this 2 rotation initial is 2 rotation. So each of them equal to central gravity rotation initial. This one m. Okay, this is 12 m r square. This is central gravity on this line, central line rotation initial. This one plus this mass times distance. Mass is pin. Distance from here to here, which is equal to this one minus 180 minus 30 minus 60 equal to 120. 120 divided by 2 is 0.06. Get the radius 0.06. Okay, so put all this data inside. Put all this data inside. You calculate equal to 0.003128. 89. That's you get the results. Okay, very simple. And then we go to next question. For this structure, how can you calculate this rotation initial? This structure. So this structure has 3 parts. 1, 2, 3. So you calculate this part to the rotation, multiply 3. That's good enough. So in order to calculate this part rotation according to along this O, then you should, along the central gravity, should be 12 ma square. Central gravity rotation inertia plus the mass times this distance. The key is this distance. How much? This distance equal to half of a tangent is 30 degree. Half of a tangent 30 degree. Okay, m square. And then you put all this data inside, and you organize, you find it's half ma. That's total result. Okay. Then we move to the next question. So we have what is the next question? Next question is you have a pendula consists of the plane and have a mass of 6 kilogram, and also a slender roll have a mass of 2 kilogram. Okay, determine the radius of gyration of the pendula about the axis perpendicular to the page and pass through the O. This is the rotation initial. So how can we do this one? Rotation initial of structure along this O equal to mass, total mass times radius, RO square. Okay, that's we know that. So rotation total mass is this mass plus the low mass, which we given the mass is 6 plus 2. Okay, 6 plus 2, the total mass, and RO square. 6 plus 2 is 8 RO square. This is total rotation initial. And total rotation initial should be each component. This rotation initial plus this rotation initial. This rotation initial equal to central gravity rotation initial, okay, which is 12. Okay, 12 as 12.m equal to should be equal to IP. Okay, IP and plus mass to SP. Okay, plane. Okay, IP is 12 m square, right? 12 m square. I think this should be 12 m square. And then 12 m square, this m square is radio is 0.2 sides of m square, okay? And radio r square, this is radio m square, okay? This is a rotation initial, right? ml square, and plus the mass 6. And the distance from here to here is 1 meter, and this 1.25, 1.25. This is the first this part of a rotation initial, and the part of the law is the mass. The law equal to central gravity. The initial is 12, 1 of 12, okay, 1 of 12, and 1 of 12. The mass m times this total length 1.75. Total length. So m times total length, half of ml square. Okay, and the plus the central gravity, half of this length, central gravity to this distance. This is equal to 1 minus half of this one. Half of this is 1.75 divided by 2. Use 1 minus this one. That's to get the central gravity mass 2 to this distance square. Okay, and then you put inside, calculates. Inside, you calculate total equal to 10, and r square equal to 10, and you solve the ro equal to 1.12 meter. That's you get 1.12 meter. Okay, 1.13 meter. That's how you get. So total definition for the rotation initial equal to total mass times ro square. That's we define. Okay, we define. So total mass A times r square. But the total in rotation initial equal to each component. This rotation initial plus this rotation initial. This rotation initial, central gravity rotation initial 112 m the length square, and the plus central mass 6 times distance from here to here. This 1 plus 1.25 square, and this is the rotation initial, and the plus this law rotation in the central gravity rotation initial, which 12 1 over 12 ml square. L is 1.75, and from then go to the central gravity center position is 2 mass 2. Central gravity to this rotation distance, and this distance equal half of length, which total length is 1.75. Half of length, this is half of length. 1 minus this half length, this distance. That's why you get this one. And then or you calculate together equal to this one. And this divided by 8 square root 2 equal to 1.12. That's why how you solve this problem. All right, I think we finish all today. Any questions? We still have a little bit time, okay? So any questions? Now time is up, 11:30. I will see you tomorrow. Okay, see you tomorrow. Okay, thank you. See you tomorrow.